Hello and welcome to this video about completing the square. The learning target for this lesson is using completing the square to write functions in vertex form. So let's talk about why we even call it completing the square, because there will be a square in the way we do this, but it's not why we call it completing the square. So when we say square, we're talking about that, where we square a number. And earlier, when we were looking at polynomials, we were learning how to FOIL and whatnot, and we would do something like x plus 3, and then to kind of mix things up a little bit, I'd do that. And I'd be like, hey, what's that? And we would be like, all right, well, we have to do, in order to do this, you have to write it out twice. X plus 3 times x plus 3. You can then FOIL it, and you get x squared plus 6x plus 9. Now, this we called a perfect square trinomial. Perfect square trinomial. So what this boils down to is we could say that this x squared plus 6x plus 9 is the same, or is equal to x plus 3 squared. This again is all the square that we're talking about when we're saying complete the square. Our goal here is to make a trinomial that's a perfect square. We're going to have to add something in to sort of complete it, to make it perfect. And then we'll probably have some stuff off to the side that we'll have to deal with, but that'll be fine. But that's kind of where we're going with all of this. And so let's talk about, why are we learning this? What's the point of this? How does this help us in the grand scheme of things? Well, all it has to do with switching forms. If we're starting in vertex form or factored form, and we want to go to standard form, which is our ax squared plus bx plus c, all we have to do is FOIL and simplify, combine like terms, all that stuff. And that gives us standard form. And standard form gives us some nice information like c. That's a really easy point to plot on the graph. But if we want to go from standard form to vertex form, this is where we use completing the square, which we'll abbreviate CTS, completing the square. And so we're able to take ax, so let's just draw it out. We go from ax squared to bx plus c, and we're able to take that to a times the quantity x minus h squared plus k. So enough yakking. Let's start. Well, actually, we're going to do a little more yakking. Sorry. We're going to talk about the process and the goal. So our goal is to take something that's ax squared plus bx plus c, and what we're going to do is turn it into x plus or minus something squared plus or minus something else. And there may be a number there. That's the goal. Now, the process is to first of all make sure that we are in standard form. After that, what we're going to do is focus only on A and B. Now, here's what's going to get a little more confusing. I'm going to write it down so that way it's in your notes and you have it, because it will help you. These are, step-by-step instructions, kind of like, a recipe for cooking. We are going to divide B by 2, square it, and add and subtract it. I probably lost you there. It's okay. You'll find out why. Finally, we rewrite as a perfect square trinomial, or we rewrite the perfect square trinomial that we've just cooked up as x plus or minus b over 2 squared plus or minus something. Makes sense, right? Okay, so let's look at some examples and take it from there. So let's start off with f of x is equal to x squared plus 6x plus 2. Okay, what I want to do is make sure it's written in standard form. It is. Now I just want to focus in on these, A and B. And so I'm going to sort of spread things out a little bit. I'm going to write it as x squared plus 6x plus, and then I like to put a box here, plus 2 minus a box. Now here's the thing. We're going to dress up this part of the quadratic function that we have. We're going to add something to make it look like a perfect square trinomial. We're putting a Halloween costume on it. Now, we just can't randomly add numbers. So if we add something, we have to subtract something. And these are just numbers, so they'll combine, and eventually everything's going to all, sort of, or will all be evened out at the very end. It kind of reminds me of around, like the holidays, and you give your friends or coworkers or something like that gift cards, and it's just like you exchange $10 with everyone, because everyone got everyone a $10 gift card for Starbucks. And so it's like, we did all this work for nothing. It's kind of similar to that, where we're going to be adding something, but at the same time we're going to be subtracting something, and it's still going to be the same. It's just going to look different. So, for example, now step 2 was to focus in on B. It's 6. So what I'm going to do is I'm going to take my 6, I'm going to divide it by 2. That gets me 3. I'm going to square it. That is 9. So I'm going to put a 9 here. I'm going to put a 9 there. That's what I was talking about over here when I said add and subtract it. We're adding it and we're subtracting it. Now, let me erase this little mess right here. I'm going to take this, and that is a perfect square trinomial. And I'm just going to, again, focus on it separately, and I'm going to rewrite it as x plus, these signs will always match up, and then I take this term, my 6, divide that by 2, which is 3, make that x plus 3 squared, plus these two, negative 7. I've now written it in vertex form. I know, it might not look like we've done much, but let's keep doing some more examples and see if we make sense of it. Let's do another one. So f of x is equal to x squared plus 12x minus 3. Okay, so again, what I'm going to do is just focus on these guys. X squared plus 12x plus something minus 3 minus that same something. All right, off to the side here, I'm going to do a little work. I'm going to take 12, I'm going to divide it by 2. That gives me 6. I'm going to square 6. That gives me 36. 36 is what's going to go in my boxes. 36, 36. Now, for this part, I'll get x plus just that number right there. It's always going to be that number. So that's going to be 6, quantity squared, minus 3 minus 36 is minus 39. And I've rewritten it in vertex form. Let's do one more example. F of x. Oh, actually, let's do some hard examples. We might do 2 more. Okay, so f of x is equal to 2x squared plus 7x plus 6. Okay, here's where it gets real. Because we have a is not 1. It's another number. So we're still going to focus on this. But here's what I'm going to do. I'm going to go 2, and then I'm going to factor that out. X squared plus 7 over 2 x plus something, parentheses, plus 6 minus, now here's the thing, I'm not just going to put minus box, I'm going to put minus 2 box, because eventually I'd have to distribute this 2 here, and I'm adding something, or whatever I'm adding, I'm timesing it by 2 first. So I have to subtract 2 times that same thing. Now, the numbers look nasty, but fractions are your friends, and we just follow the process. So off on the side, I'm going to take this number, and I'm going to go 7 over 2, and I'm going to divide that by 2. That's the same thing as doing 7 over 2 times 1/2. This is where knowing your fractions and whatnot makes life a little easier for you. This gives me 7 over 4. Now I'm going to take my 7 over 4 and I'm going to square it, which is the same thing as 7 over 4 times 7 over 4. Meaning that what I'm going to add in my box is going to be 49 over 4. 49 over 4. 49 over 4. Okay, now I do the rewriting step. So the 2 is going to come along down here, 2. In here, I'm going to write x plus, and it's going to be something squared. And again, it's just that number right there, 7 over 4. And then here I will have to do a little bit of arithmetic. So these 2 are going to become 2. And so now let me see here. This would be 12. No, not 12. Yeah, 12 over 2 minus 49 over 2. 49 minus 12 is going to give me 37. So it's going to be minus 37 over 2. It's not pretty, but we've done it. And occasionally we'll run into problems like this. So when you're doing these, this is where you become a person of faith, and you really hope and pray that, first of all, this number is 1. And second of all, that number is even, because it just makes your life so much easier. But even if it's not, you can still work with it. It's possible. We follow the exact same steps. We take this middle number, we divide it by 2, like I did right here, and then we square it, and we just kind of roll with what we have. And if you need to, we have calculators to help out with all these tedious computations. So, good luck with your homework or practice, and let me know if you have any questions.